Greetings, class. This is my test correction submission. For my first problem, the problem that I wanted to review from the test was one based on projectile motion. This is one that I feel like I definitely could have done better on. This is one that I actually did get a majority of points for, but I forgot some key steps that would have helped me get the answer. So for this first problem, we're supposed to determine the flight time of the ball and the corresponding distance of D covered. So I'm gonna write that down. The next step, I want to actually draw this out that we were given. So this is X, this is Y, our V naught, and then our beta going this way. Okay, so we're given that V naught is equal to 15 feet per second, and that this angle is 45 degrees. Okay, so first off, we have to make some equations. So the part that always messes me up is substituting equations. So we start off with that the ball is, the coordinates of the ball as a function of time are this. So we have x of t and y of t. So given that it's going in this the x direction, gravity doesn't play too much of a part on it. But in the y direction, it does, which is why we have this other component, which is the 1/2 gt squared. Okay, so after that, we make components using the x dot and the y dot as well. And this is where the sort of substitution part comes in. So we see that x is corresponding to cosine and y is corresponding to sine, like normal. So now that you substitute these in, you're left with this for x direction, and then this in the y direction. So now using this, we're gonna use a TF, and this will be corresponding to the time the ball comes back to the green. So this is by the time it lands here. So using this formula that we've derived, V naught TF sine beta minus 1/2 GT squared F. So now we're gonna choose it to solve for TF. So now we move everything over. We substitute everything in. It gives us that TF is equal to 0.6588 seconds. Okay, now another substituting part is where we find our distance. So you substitute this last piece of the equation, this TF, into this equation that we had before for the x. Which now gives us and then upon putting these in, our final D is equal to 6.988 feet. So this is our answer for this. Come up to our second example, and this is going to be another projectile motion about a rock going over a house. This one's going to be a little bit quicker. Sorry, this is supposed to come over some. You got a bigger distance of 8, and then an arc that comes around. I'm definitely not the best artist, but it's supposed to look something like this. And this is where the ball starts. Okay? So to start this out, we need to find the max height. Max height was found from doing 8 meters minus 1 meter, and that would be our 7 meters. Now we use a formula for max height, which is this. And we solve for this u squared, which is just this. So now this is moved out. I'm gonna go ahead and plug some numbers in here. So 2, then we have gravity, which is 9.81 per second squared. We have the 7 meters. And then we have sine squared 40, which is equal to 18.23 meters per second. Remember, you had to do the u squared, and this is what it is after that. So then, in order to find the final meters, derive another formula. And then from here, you use this u squared value, which is 300. Then you do sine of 2 times 40. Then again, 9.81. All right, and then from here, I believe those units are correct. Should be extra squared here. That's the way all it comes out to is equaling 16.68 meters. Then you do this 16.68 meters minus 4 meters, and this 4 meters is coming from the x direction, this x direction distance, which is right here from the edge of the house to the middle of the house is 4 meters. And this is where this number is coming from. So after this, you're left with this answer, which is 12.6845 meters. And this is your final answer for this, as well as the final time. So here, all it wants us to do was find this initial velocity and then this final distance. So in total, with both of these problems featuring projectile motion, something that's a little harder for me is trying to figure out what kind of substitution you have to do in order to make certain equations work with each other. And also another part that's more difficult for me is kind of visualizing these. So if you can find a way to visualize it, to picture it out in your head, and actually to see it, and to make sure you're drawing things correctly, drawing angles correctly, correct velocities and such to get certain equations, problems will come out correct.